best ways that we can get started with problem solving in a primary classroom is through literature. When I was teaching primary for many years, kindergarten and first grade, I always started with a book or a story or a song or something that got the kids engaged with a real life context, and we would use it in a variety of ways. So we might take a story. One of my favorites was Over in the Meadow. And there are many other counting books, but Over in the Meadow was a great one to get started with. So at the beginning of kindergarten or the beginning of first grade, we might just start our math block or our math discussion with a story like this one. Over in the meadow, in the sand and the sun, lived an old mother turtle and her little turtle one. Dig, said the mother. I dig, said the one. So he dug all day in the sand, in the sun. And I might use some manipulatives to represent that because we want to help kids make the connection between what's a living thing or what's a real thing, something that we could actually touch, and something we could use to represent that thing. So I might, for example, use one Unifix cube. So I would talk to the kids about how this is going to represent one animal in the meadow. Over in the meadow where the stream runs blue lived an old mother fish and her little fishes too. Swim, said the mother. We swim, said the two. So they swam and they leaped where the stream runs blue. So again, I would use the Unifix cubes or tiles or any other manipulatives I have available to represent that. Well, we had one turtle, but now we have two fish. So we'll represent the two fish with the two orange cubes. Over in the meadow in a hole in a tree lived a mother bluebird and her little birdies three. Sing, said the mother. We sing, said the three. So they sang and were glad in the hole in the tree. Now we would stop and talk about it. How many bluebirds were there? How many Unifix cubes would I need to represent that? I would need 3. So we would build that together and stop and talk about it. And as I was reading, I would probably stop and talk about what was happening in the story, what was happening in the pictures, just like you would in any read aloud. Have them make some predictions. What number do you think will come next? First we had 1 turtle, then we had 2 fish, then we had 3 birds. What number do you think will happen next? Over in the meadow, in the reeds on the shore, lived a mother muskrat and her little ratties. And stop and let the kids fill in the number. They like the rhyme of the story, they like the pattern, they like the rhythm. So we could build the 4 muskrats with 4 Unifix cubes. And again, we're going to go back and talk about what's happening. The kids are going to start to notice, wow, it's getting taller. First we started with 1 turtle, then we had 2 fish, then we had 3 birds, and now we have 4 muskrats. What's happening to our number? It's getting bigger. We can talk about growing patterns. We can talk about how it's increasing by 1 each time. What number do you think will come next? Let's read on. Over in the meadow, in a snug beehive, lived a mother honeybee and her little honeys 5. Buzz, said the mother. We buzz, said the 5. So they buzzed and they hummed near the snug beehive. So again, we're going to represent our bees with 5 Unifix cubes or 5 tiles or whatever math manipulative we might want to use. I think Unifix cubes lend themselves well to this particular kind of activity because you can stack them and the kids can see the growing pattern as you're building and modeling for them and talking about it, what's happening, what number do you think will come next. If I were starting this off in the beginning of kindergarten or even maybe first grade, we might stop the story even though the story goes on to 10. And we could keep going if we thought our kids were ready for that. But we might just stop and talk about how we could represent that. First we represented it with Unifix cubes. We could act out the story first and then read it again and then use the cubes. The kids like to act out the stories, and so I would probably have them do that and have volunteers act it out 2 or 3 times. And then we would stop and talk about ways that we represented our numbers, our number of animals. And then, of course, we could represent it other ways. We could represent it by drawing it. We could talk about that. One of the things we might want to do is turn it into a problem. So you could take a simple story like Over in the Meadow. We've read it together, we've acted it out, maybe acted it out multiple times. I've modeled with some manipulatives to show that you can represent the animals in one way, but we want to talk about some other ways we could represent them, and we want kids to be thinking a little bit so we could turn that into a problem. For example, I came up with this problem. How many animals were over in the meadow? Now, in the example, I stopped at number 5. So there was 1 turtle, 2 fish, 3 birds, 4 rats, and 5 honeybees. So I'm asking the question, how many animals is that? Well, we want to read the problem and read it again. So we would read it with the students and ask them to choral read it with us. How many animals were over in the meadow? Step 2 is to think about what do we know and what are we trying to find out. Well, let's go back to our story. Remember, in our story we would talk to the kids about that. What do we know? Well, we knew that there was 1 turtle. Okay, we could write that down again. There was 1 turtle. We could use numerals to do that, especially in the beginning of kindergarten and even in 1st grade when they're still starting to recognize their numerals or remember their numerals. We want to make that connection with them. What else do we remember? We also remember there were 2 fish. So we're going to write down and model that process with the kids. What do we know? We know that there were 3 birds. So we could write that down as well, 3 birds, and so on. So we know what animals we read about, 1 turtle, 2 fish, 3 birds, and so on. What are we trying to find out? Well, what is our question? Our question is, how many animals were in the meadow? Okay, so now it's time to make a plan. What is our plan? What is one way we could find out? We would talk to the students and elicit their ideas about that. Some kids would say, oh, we could build it like you did when you read the story. So we could get our Unifix cubes or our tiles or our beams or whatever we're using, and we could build that. 1 turtle, 2 fish, 3 birds, 4 rats, muskrats, and 5 honeybees. Well, what would we do now? We're trying to find out how many. Most of the students would say, oh, well, you can just count them up. Let's go ahead and do that. Right? So we could count them up: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So we know that by counting, we found out that there are 15 animals over in the meadow. What was another way that we could have solved that problem? We want to talk about that. What if we didn't have cubes to do it? What's another way we could do it, for example, on paper? Some of the students said, oh, well, we could, draw a picture of all the animals. Sure, we could do that. And that's something I used to do with my own kindergartners. I would have them actually represent all of the animals that we learned about in the story and then see if they could count them up. It was a great formative assessment for me because I could see, first of all, who actually had who was able to correspond the number of pictures with the actual number in the story. So for example, did they draw 2 fish? Or did they just draw, 1 turtle, 1 fish, 1 bird, and so on? Some of the students would do that at the beginning of the year. Others would draw 1 turtle, and then they would draw 2 fish, and then they would draw 3 birds, and so on. And then they would be able to count them up, or maybe they wouldn't be able to count them up, and that would tell me something too, that they had the one-to-one correspondence, but they weren't able to count to 15. So again, it was a great formative assessment. With 1st graders, or even into early 2nd grade, you could turn that problem into an addition sentence. Kids can represent it many different ways. Some kids would say, oh, I can represent that with tally marks or with circles, because maybe it's going to take me a long time to draw all those different animals. And I would encourage that, because eventually we want them to move away from drawing the whole picture and to really get at the math part of it. So early on in the beginning of the year, kindergarten or even 1st grade, I might allow that as a formative assessment to have them draw a detailed picture as a poster, as an assessment, something that I would keep in a portfolio that I could come back to and give later in the year and see if they made some progress. Or maybe we would just talk about there are faster ways to do that, depending on what my goal was. So I used to say to my 1st graders, gosh, I could do that, I could draw all those pictures, but that might take me a really long time. Is there a quicker way? Oh, well, we could draw 1 circle to represent the 1 turtle, or we could draw 2 more circles to represent the 2 fish, and then we could draw 3 more circles to represent the birds, and so on, and then they could count up their circles. Other kids would say we could use tally marks, 1 for a turtle, and 2 for the fish, and 3 for the birds, and so on, and count it up that way. There are lots of different ways they could represent it. I've even had a lot of kindergartners and early first graders who would use numbers to represent that. So they would say 1, and then 2, and then there were 3 birds, and then there were 4 muskrats, and there were 5. And we would talk about how would you count that up? And that gets at the problem solving and the reasoning. What are some ways that you could figure out how much that is altogether, 1 and 2 more and 3 more, and can we represent that? Again, depending on what your goal is and how far along your students are, you might represent that as an addition sentence. 1 plus 2 plus 3 plus 4 plus 5 equals, we don't know. How could we find that out? And again, you can use that as a formative assessment as kids write in their journal or write on the paper, on scrap paper, on whiteboards, whatever they're working with. I like to keep it on paper so that I can keep it in a portfolio, I can revisit it, and I can look at it after school, and I can look at it later in the week and see where kids are in their thinking. So they made a plan, they're making a plan, they might use the cubes, they might draw it out, they might use circles, they might use an equation. They're going to make a plan, and then they're going to implement that plan, and they're going to do that typically individually. I used to ask my students to work alone in the beginning before they shared it out with a friend. So they could work alone, or you could have them working with partners, again, depending on your goal. So they're going to implement the plan that they came up with. So again, we're working through a 4-step process. First of all, read and reread the problem. Second, find out what we know and what are we trying to find out. And again, this is going to take a lot of modeling on the teacher's part, especially in the beginning of the year. Once students get used to this 4-step process, they make it a part of their everyday math solving. But in the beginning, it'll be almost like think aloud. So I might start with a problem and say, gosh, I don't know, it's going to take me a long time to draw all those pictures out. I think I'm going to use circles. So I might start by modeling that process with a problem and then give the students another problem to work on, either alone or with a friend. So you can do it a number of different ways, but it is going to take quite a bit of modeling in the beginning of the year to help get kids get into that problem-solving, 4-step problem-solving steps. So we want them doing the problem-solving. We want them reasoning about their solutions. So we want them to communicate as well. One of the things I always had the students do as the 4th step is to share it with somebody. They always shared it with me, but I always wanted them to share it with others as well. Because sometimes that's when they would see, oh, I got a different answer than you did. Why is that happening? And typically as a teacher, I would say to them, well, I noticed that you and Jeanette got a different answer. Why do you think that happened? Do you think both of you are right? Is only one of you right? How could you figure it out? Why don't you work together and see if you can figure out why you got different answers? Maybe there is more than one answer depending on the problem, and maybe there is only one answer. For example, in this case, the answer is 15, and maybe I got 13 because I counted wrong. Maybe I discover that when I share that with a partner at my table. So I always ask them to share it and then have them write down the person's name here, or the other person could sign it saying, I read this problem with my friend. So once they've done the 4 steps, they've really gone through all of the problem-solving goals. They've gone through problem-solving. They've reasoned it out. They've communicated their mathematical thinking. They've made some connections to the story or to a real-life situation. They've represented their thinking. So we want them doing this on a regular basis, and we do that through starting with a context that's exciting and engaging with the students and making an engaging problem. Here are some actual examples that were done by preschoolers, kindergartners, and first graders. You can see that Emily has lined hers up and almost made a graph, whereas Theander drew each one of the characters in the story, and then she counted up how many there were altogether. Nevian did the same, drew all of the characters, but also labeled them with both numerals and numbers, and then counted up to find 15 total, which you can see at the bottom. So let's talk about what we've done so far. First of all, hopefully we set up an environment in our classroom right from the get-go by allowing kids to share their ideas, by creating a class culture that makes it okay to make mistakes, that makes it okay to share, and makes it okay to disagree with somebody if you disagree, and how do you disagree with somebody politely. We have set up our environment where students are working together at times and have alone times. We set up an environment where kids can work at stations after they finish the problem. The environment is something that we're setting up at the beginning of the year, and we're spending all year reinforcing that and making it better. We've done our Engage and Hook. Our Engage and Hook was our story. The kids were excited about the story, we read the story, we acted out the story. We gave some explore and apply time. We gave them a problem to explore and to come up with a plan and to implement the plan. So they're applying their problem solving, they're applying their reasoning, they're representing their thinking, they're communicating with others. So we've provided that time for them. After the kids have had some time to work on the problem and share it with somebody, maybe then it's a good time for them to go off and do some more explore and apply at math stations or math games. And we want to provide some time for them to do that. Maybe I want to pull a small group at that point. Maybe some students were really struggling with counting and I want to do a mini lesson with them on counting. Maybe some of my students were ready for much more and I want to pull some kids together and do an enrichment problem or an enrichment activity with them, while others are working at stations or others are working on problems or others are working on math games. So the explore and apply is going to be a really important part of our math instructional block. But what part have we left out? We haven't done anything with explain and model yet. Well, we did a little explanation, we did a little modeling at the beginning, especially near the beginning of the year when we want to model that four-step process. As the year goes on, we can move, allow the students more of the independence to do that on their own, to release that problem-solving process to them. So we wouldn't want to do quite as much explain and model at the beginning, perhaps. But now it's time to gather together again. We want to do some more explanation and modeling and pulling out the math. So we'll pull them together and do a math talk, and we want to talk about some of the strategies. What I learned over time is that it isn't necessarily a share time for everybody because we have limited time, don't we, in a 60-minute instructional block. So what I tried to always do is to pull out the math purposefully by noticing how different students solve the problem in different ways. And maybe we would only share 2 or 3 different ways that students solve the problem. And I want to pick out, I want to be purposeful in deciding whose ideas I want to share. So I might say, you know, John, I really like the way that you were able to explain your answer. Could you model that for us? Or maybe I would say, I noticed that Jaman, I noticed that you solved it in a completely different way than others at your table. I'd like you to explain the way that you thought about the problem. And I would have Jaman explain how he did it, and I would model it up here. Sometimes it's good for the kids to come up and model it for themselves. Sometimes that takes a lot of our math talk time. So oftentimes I would ask kids to explain it to me, which also reinforces their learning when they have to explain their thinking once again to me or to the group. So as he's explaining the way that he solved the problem, I'm modeling it up here. So for example, maybe Jeanette said, well, I drew circles to solve the problem. Well, tell me what you did. Well, first I drew 1 circle. Why did you draw 1 circle? I drew 1 circle because that represented 1 turtle. Okay, what did you draw next? Well, then I drew 2 circles because 2 circles represented the 2 fish. Okay, let me go ahead and do that. What did you do next? Well, then I drew 3 circles, and so on. And so while Jeanette's explaining how she did it, I'm modeling her thinking right up here. Well, what did you do next? Because the problem said how many animals were in the meadow. How did you find out how many animals? Oh, well, I just counted the circles. Let's all do that. Or Jeanette, can you come up and show us how you did that? Or let's all count this together and find out how many. Is that the answer that you got, Jeanette? Okay, so we want to talk that through. Maybe I had a student who used numerals and figured it out as an equation. Talk me through that. What does this 1 represent? Oh, 1 fish. Okay, so what did you do? Then I said plus 2. Okay, why did you put 2? Oh, 2 represented the, 1 was the turtle and 2 was the fish. Why did you put a 3? What was the 3 standing for? 3 stood for the 3 birds. What is this plus sign? What's that all about? That means we're adding those numbers together. What does it mean to add numbers together? So we want to do some inquiry. We want to ask good questions and ask the kids to explain explicitly what they were thinking and what they did as we model their thinking up here. Okay? So I might say to Jamon, wow, you've got all these numbers. How did you find out that the total was 15? What did you do to figure that out? Well, maybe he got some tiles out and counted the tiles to help him. Maybe he drew some tally marks underneath, 1 and then 2 and then 3. Maybe he drew some circles, 1 and then 2 and then 3. Or maybe he's got a really good deep foundation for number and number sense, and maybe he's already doing some addition and subtraction. Maybe he knows some combinations of numbers. He might say, well, I know that 2 and 1 makes 3, and I know that 3 more makes 6. And then I counted up 7, 8, 9, 10, and then 11, 12, 13, 14, 15. Kids will have lots of different ways to think about that. Some kids might use a number line if they've had a lot of experiences with a number line, and they might start at 0, and then I added 1 for the turtle, and then I added 2 more for the fish, and that got me to 3. And then I added 1, 2, 3 more for the birds, and that got me to 4, 5, 6. And so on. Students will have many, many different ways and strategies. We want to encourage those. So for example, if I saw that Tom had used a number line, Jamon had used an equation, and Jeanette had used circles, not only does that tell me a lot about their problem solving and their understanding of number and number sense, and provide good formative assessment for me that I want to be jotting down, but it also allows students to see other ways to solve that problem. So maybe Jeanette solved it by drawing circles, and she says, wow, that really made sense to me what Jamon did. Maybe I'll try that next time. Or maybe she says, wow, I didn't really understand what Jamon did, but I really liked this idea of using a number line. And maybe next time she'll take ownership of that and make that her own and try that strategy out. It's the sharing of the strategies, it's the sharing of the thinking that really enforces the explain and model piece.